Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and I am back with another another video about trigonometric graphs. Now, this is the one section for me where I believe students can score a lot of marks. But because it's actually relatively easy, I have found that my students, are lazy. They go, I know it, I got it. And then they just quickly browse through it and they don't really handle, the trig graphs proper. So I'm going to go through this step by step on how to answer trig graphs. So I want to ask you, first of all, go and do the sum yourself. Sketch the graphs and answer the questions. Now, I just want to say 6.2.2, don't worry about that one at all. It's actually matric work how to do that. Okay? You go and try the rest. If I look at this question 6.1, given that fx is that and gx is that, sketch the graphs of f and g on the same system of axes for the interval between -90 and 180 degrees. First of all, let's start with fx. fx is a normal tan graph, and I'm therefore plotting the points that is for a normal tan graph. Now, I know there's a -1 there. Please get that. I know there's a -1. But let's just first plot the normal tan x graph. So the tan x graph looks like that, with intervals every 45 degrees. Okay? Where does those intervals come from? Well, remember taking the period, dividing it by 4. So 180 degrees over 4, which gives me 45 degrees, which means every 45 degrees, something special happens, both in the positive direction as well as in the negative direction. Now I ask myself, what does that -1 do at the back? It takes my mother graph, my original graph, and it shifts it 1 unit down. So I'm going to literally take every coordinate and move it 1 unit down. Okay? So if I take every coordinate and move it 1 unit down, the 0 becomes -1. The 1 becomes 0 at 45. And the -1 at -45 becomes -2. So this means my graph is like that. Every single set of coordinates is just moved 1 unit down. Okay, that is relatively straightforward and simple. Okay, let's have a look now at drawing the cos 2x graph. But for me to draw the cos 2x graph, I must first of all understand what the 2 does in front of the x. The 2 means in a normal cos graph, I'm going to fit 2 cos 2x graphs in. So in other words, my period is now the normal 360 divided by 2. Which means my period is 180 degrees. Again, now I can get my intervals. Taking my period, dividing it by 4, I'm getting 45 degrees. So every 45 degrees, something special is going to happen. So our normal tan or cos 2x graph starts at its amplitude, which is 1. And then every 45 degrees, something special now happens. So from 1, you see it goes down to 0 at 45. At 90 it goes to -1, because every 45 degrees something special happens. Please remember, it has an amplitude of 1. And there, ladies and gents, you've got 5 marks in your pocket. Now let's look at the next questions. The next set of questions, I just redraw my graphs. I redrew my graphs just so that we can keep it close by when we answer question 6.2 and question 6.3. So at question 2, it says determine graphically. So in other words, using your graphs, determine the following. 6.2.1, cos 2x plus 1 equal to tan x. But wait, how can they ask me to draw this, to determine this graphically? I haven't sketched cos 2x plus 1. But wait, what if I transpose that plus 1? Then I get, oh my, actually, they're just asking me where is g of x equal to f of x. So in other words, where do these two graphs intersect? Only at one place, at 45 degrees. Okay, plain and simple. Now 6.2.2, ladies and gents, as I said earlier, is actually a matric level question. So I am not going to look at answering that question because it's just going to confuse you, okay? It requires some identities that you actually only learn in matric. So I'm going to scratch that one out. But now 6.2.3 is where we start asking ourselves, where is fx multiplied by gx greater than 0? Fx is the y values of the red graph, and g of x is the y values of the green graph. So I'm going to start by analyzing my graph, the y values. First of all, there I've analyzed the green graph. Whoa. Let's just quickly recap. So how did you do that? Well, first of all, there on the left-hand side of -45, my y's are negative. Then it jumps above and it becomes positive. Until 45, then it goes negative again all the way to 135. Then it jumps to positives again. Now let's look at g of x. Okay, on the left-hand side of 0, my graph is negative all the way till 45. Then it becomes positive all the way to 90. Then it starts negative again all the way to 180 degrees. So what are we looking for? I'm looking for a positive times by positive or a negative times by negative. So let's divide our intervals, our graphs, into where graphs change from negatives to positives. So by negative 45, 45 and 135. That's going to be my starting points, okay? So when I look at these intervals between -90 and -45, I've got a negative times by a negative because remember my red graph is negative. So that works for me. But now between -45 and 45, I've got a positive times by a negative. So that doesn't work for me. Between 45 and 90, I've got a minus times by a plus. And then between 90 and 135, I again have a minus times by a minus. That works for me. Now the one point that I've placed that I forgot to indicate was between 135 and 180, I've got a plus times by a minus, which doesn't work. So this means there are two places it works, between negative 90 and negative 45, and between 90 and 135. And that's my answer. Again, why do I use round brackets? First of all, at negative 90, my tan x graph is undefined. As well as I'm having just greater than 0, not equal to 0. So I cannot include 45 or negative 45 or 135 because my graphs is equal to 0. One of the graphs, or maybe even at 45, both of them equal to 0. But I'm not looking for equal to, so I use round brackets. Now, last and not least, 6.3. Write the equation of h of x, the result from shifting g of x 30 degrees to the right. So if I'm shifting g of x to the right, remember, it means inside the x value, I'd say it's x minus 30. So in other words, g of x, which is cos of 2x, inside the x, it now becomes x minus 30 degrees. They try to kind of catch you out because a lot of students are going to say this. I can almost guarantee you that. And that is wrong, okay? Simply because it's not inside the x that this is being moved. So please be very, very, very careful when you are shifting left and right that it has to be inside by the x. This is Mr. VG signing out, and I'm glad that this is still going to be recorded, even though load shedding just happened while I'm recording this. Man, life in South Africa is never ever a dull moment. So have a beautiful, amazing rest of your day. I hope that you have electricity wherever you are watching me from. Keep safe. And please enjoy the next video, which is going to be about non-right angle triangles, so solving triangles. This is me signing out. Cheers.